In this lesson, we're going to talk about some of the typical blocking agents which are available for you to choose from. Several protein-containing blocking agents are commonly used for what we term homemade blocking solutions. These include non-fat dried milk powder, otherwise known as NFDM, bovine serum albumin, also known as BSA, whole serum, casein, and others. Bear in mind that protein-based blocking agents can interfere with some antibody-antigen interactions, and additionally some blocking proteins may be recognised by primary or secondary antibodies, which could cause high background. To overcome this, some blocking agents will use non-animal proteins or synthetic proteins to prevent cross-reactivity with primary antibodies which are produced in animals. Non-fat dried milk is a commonly used blocking agent, and it's generally fairly good for this purpose. It's inexpensive, it's easily prepared in the lab, and it's readily available. However, it should never be used if you're detecting phosphorylated proteins. Milk itself contains casein, which is a phosphoprotein, as well as other phosphoepitopes, which can be recognised by the antiphospho antibodies, leading to non-specific antibody binding and high membrane background. Milk is also not recommended if you're detecting anti-goat secondary antibodies, as these often cross-react with the bovine IgG which may be found in milk, again causing high background. And finally, milk is incompatible with avidin-biotin detection systems, as milk itself contains biotin, so this will lead to very high background in these cases. Bovine serum albumin, also known as BSA, is another commonly used protein-based blocker. It is a solution comprised of a single protein purified from cow serum. Similarly to milk, it is easily prepared in the lab. Unlike milk, however, it can be used for detecting phosphorylated proteins and is compatible with avidin-biotin detection systems. It's also not recommended if you're using anti-goat secondary antibodies, as these often cross-react with the IgG which can be present in BSA. Because BSA is a single protein, whereas milk comprises numerous mixed proteins, this means that it is less likely to hinder antibody binding. However, this characteristic means that BSA can be less versatile, and typically can result in more variable performance from target protein to target protein than you can expect with milk. But more importantly, BSA fluoresces, and therefore it can cause high background, and we would not recommend that you use BSA for near-infrared Western blot detection. An alternative to non-fat dried milk, or BSA, is to use casein as a blocking agent. Casein, a protein which is purified from milk, is cheaper than BSA and can be used in largely the same situations as milk. It is scientific grade, however, and that means it can be used at lower concentrations. However, like BSA, it is a single protein and is therefore less versatile as a blocking agent. It also has the same drawbacks that non-fat dried milk has, and therefore it is not recommended for detecting phosphorylated proteins. Yet another alternative blocking agent is to use whole serum. Typically, this is derived from horse, fetal calf, rabbit, or goat. It is more expensive than milk or BSA, and offers little practical advantage for Western blot applications. Therefore, it is less commonly used as a blocking agent. Whole serum contains immunoglobulins and serum proteins which can potentially cross-react with primary or secondary antibodies, which can also lead to high non-specific background. Commercially available blocking buffers offer some advantages over the homemade solutions that we've already discussed. These advantages include an increased shelf life and improved consistency from batch to batch. Also, many of these buffers are multi-component solutions which perform better than a single blocking agent such as BSA on its own. Intercept blocking buffers from LICOR are formulated to provide highly efficient blocking and low background in quantitative Western blotting applications. Intercept blocking buffers are ready-to-use blocking agents, and they are available in either a TBS or a PBS-based solution. These contain no mammalian proteins for minimal cross-reactivity with mammalian antibodies. They are universal blocking buffers which are useful for detection of phosphorylated targets, and they're an excellent choice for avidin and biotin-based detection systems. And in fact, they are a great choice for any and all near-infrared Western blot detection. Some commercially available blocking buffers are offered in a protein-free formulation. Instead of using a solution of one or more proteins as the blocking agent, these solutions contain non-protein compounds which block the membrane in a similar way. Protein-free blocking buffers, for example Intercept protein-free blocking buffer available from LICOR, serve to eliminate cross-reactivity issues, which can often be a problem with protein-based solutions. Intercept protein-free blocking buffer which is available ready to use in either a TBS or PBS-based formulation, is suitable for use in assays where the use of animal-sourced products is prohibited. Like the standard intercept blocking buffers, it is formulated to provide highly efficient blocking and low background in quantitative Western blot applications. Again, it is a universal blocking buffer suitable for use in detection of phosphorylated targets and is also compatible with avidin biotin detection. So, as we've discussed, there are many different solutions available for blocking your membrane. Unfortunately, no single blocking agent will be suitable for every antigen-antibody combination, since each pair will have its own unique characteristics and properties. To determine which blocking agent will be the best for your quantitative Western blot assay, you should first test several different options. We recommend that you try a minimum of 2 different solutions, but more is always better. To make the comparison, you should prepare dilution series, keeping all of the conditions on your test blots identical except for the blocking solution. Then you can select the blocker which gives the best specificity and the highest signal-to-noise ratio for your target of interest. This will be the best blocker for that particular protein, but remember that the blocking buffer will need to be re-optimized for each new sample type or target of interest in your research. For more information on optimizing the blocking step, please consult our Western blot blocking optimization guide, which is linked in the summary. Once you have selected the best blocker for your assay, you are ready to perform the blocking step of your Western blot protocol. You should incubate the membrane in your chosen blocking buffer for 1 hour at room temperature with gentle agitation. In the next lesson, my colleague Jessica will provide some best practices for optimizing this step.